Today we're going to start sort of the new and sort of like second to last chapter of this class, which will focus on web security attack. So we saw at this point network security, we looked at application protocols, we moved to application security, mostly binary stuff. And now we're going to focus on web applications. Web applications, of course, have become the way in which we do or we provide almost every service on the internet. That's all we do in one way or another. Most of the time you don't see even links anymore. Everything has become so polished and so sophisticated that web applications now look exactly like normal application. And in fact, you cannot really tell that Google Doc is a web application and is not a, is not a standalone application like WinWord. So basically, the World Wide Web, as you know, was initially conceived as an hypertextual system. There was a guy in Switzerland, and there were a bunch of scientists that had to share results, and they decided, hey, we have this idea that you click on this thing and you go to this other page, and so we can create this online web of documents that talk to each other. Most of you have never seen this. It happens, I would say, between 94, 93, became popular around that time. I remember when my brother, who's older than me, showed me this, this thing. It was Mosaic, and you could have a graphical web page with this link that were underlined in blue, and you could go on with the mouse, and you would click, and you would go to another page. And we were like, completely stoked by this. For you, it's a given. But before then, there was a lot of textual interfaces. There was a lot of FTP, Gopher, and all sorts of very painful to use systems. Of course, we will see the web is also vulnerable to a number of attacks, and it also has right now any attack that can be generalized on the internet as this gigantic impact, because you can actually sort of scan the whole internet and find suddenly hundreds of thousands of vulnerable hosts. And in a way, the fact that we have the internet is also what brought us these large-scale attacks that can affect really large portion of the internet. And if you look at the architecture of a web application, it is conceptually very simple. There is a browser or a client that performs a request to a server that replies. But of course, you can have a little bit of intermediaries. For example, the browser could be behind a firewall that acts as a tunnel. So it actually, for example, SSL terminates this connection, analyze where you're going, so it looks into your SSL connection, and then goes out. Maybe there is a proxy. The proxy might have a cache, so if you ask for something, your request might not even go to the web server, but could be replied immediately. And eventually, it will go to the web server itself. So all these variations are possible. And on top of this, you have to add all the code that can run. So the browser initially was this very sort of flat rendition of HTML code, okay, which is, of course, hypertext markup language. But now we have introduced a bunch of client-side execution mechanisms, such as JavaScript, ActiveX, Flash, and a bunch of extensions. And then the browser itself can have a bunch of application-specific extensions that bring their own set of vulnerability issues. Also, on the server side, the server can have gateway programs, typically initially were CGI programs, but then other frameworks like PHP, ASP pages, servlets, they fundamentally execute code on when a request is made. And sometimes these gateway programs talk to a back-end application, for example, a database. So you can see that there is a lot of things that happen, and we will see that the vulnerabilities are in part due to how we communicate. So there is a lot of confusion. We will see, for example, the proxy cache can be poisoned, exactly like you would poison a DNS cache. We can have that the code of the gateway program is actually sort of like broken into by using some techniques that we have already seen, plus some new techniques. And also we can see that there is some code that can be executed on the client side and can cause all sorts of problems. There are a bunch of standards and technologies. The protocol itself, HTTP, the Hypertext Transfer Protocol, the URIs or URLs, that's how you describe the resources on the internet, HTML, XML, XHTML, how you present the data. And we will see a few of this because it's important to understand the basics of each in order to understand the problems. In fact, we will see that there are vulnerabilities in the protocols itself. So in HTTP, some of the problems are just, bad choices in the protocols. Some of them are in the protocol implementations. There are vulnerabilities in the infrastructure, in the server side and client side portion of the application. And also, as we will see, in the various intermediary in the processing of a request that can introduce vulnerabilities that would not be there if they were not involved in the actual transfer. So understanding the basic technology is important. So we do a fast technology review. So we will look at how resources are referenced, transferred, represented, processed on the client and server side. So let's start with something that most of you don't know. So there are actually URIs, URLs, and URNs. And who have seen those before? Okay, so what's the difference between a URI and a URN?
URI is a part of the URL. It's like the last identifying part.
Wrong.
I have no idea what a URL is.
Okay, so the URL is the URI is the generic way in which we identify resources on the web. So if you look at the RFC that describe this, they say URI is just a way to say there is a name for this thing somewhere on the internet. So it's a uniform resource identifier. The URL is a uniform resource locator. And so it is actually something that tells you how to get to that particular resource. So what we use with HTTP semicolon slash, it's always colon or semicolon. That's one of my colon slash. I know there is the two dots, and I never remember how you say the two dots in English. So colon slash something, you're saying use the HTTP protocol, go to this particular host, and download or do something with this resource. So by specifying also how you do the resource, you specify a URL. A URN is just an identifier. And so the right way to see it is that you, let's see. Boop, boop, boop. So everything is a URI. Okay. And then there are URLs are a subset of URIs, and URNs are also a subset of URIs. And something can be both a URN and a URL. Not really super important, but kind of an interesting thing. More interesting, you can see that the URIs have this, scheme concept and the authority, a path, and a query string. And some of them are, well-known, FTP, HTTP, Telnet. For example, this is not a URL because, this is more of a URN, okay? Or a URI. So the syntax, the scheme specifying the protocol or the framework that you're talking about, if it's a protocol and it's used to fetch the resource, then it's of course a URL. The authority is the namespace. Most of the time you have a host, sometimes a port. Very seldom you see this with the user info at. So you can actually specify also a particular user on a particular host. And then there is the path. There is the classic slash separated part, followed by a query, which is some kind of application-specific information. So these are used to identify resources, and then these resources are reached and manipulation most of the time using the hypertext transfer protocol. It's based on TCP, use port 80, and the current version is 1.1, which is an improvement over 1.0. Very simple concept. The client opens a TCP connection to port 80, sends a request. The server accepts a connection, processes the request, and sends a reply. In theory, you can have multiple requests going on the same channel. So you can ask one thing, another thing, and you will receive reply that you will match with your request. And for example, we'll see that some attacks tend to desynchronize the association with request reply, and then suddenly you can have an association of a request with a different reply, which is actually gonna poison the cache of the proxy that is an intermediary and can cause all sorts of problems. But I'm getting ahead of myself. Requests, they are composed of a header and a body. The header is as a method, get, head, post, the resource, the protocol version, and other info. You have a general header, so these are general values in the header. There are fields that are specific of the request, and fields are specific of the entity that you are requesting, and the body is considered a byte stream. The most important method are the get request, head request fundamentally only the metadata of a resource, so basic information about what requests. For example, if you have a very big file, you can do a head request. It can tell you when it has been modified, and you can decide, oh no, I already have the latest version, so you don't have to download the whole damn thing in order to understand if you're interested in that file. And then you have post, which is actually something that is used to send data to the server, to annotate a resource, post a message, submit the form data, and provide inputs to databases. There are less used methods like options, okay, that requires information about the communication options available between client and server. Put, which is a sort of variation of post that requires the entity to be sort of added under the specified resource. So if you want, is a semantically different version of post. You have something like delete that can request the removal of a resource, and also a trace method that can fundamentally ask the server to send back whatever the server observes in terms of the request that has been made of the client. And this is useful, for example, if you have many, you're a client, you're sending a request, there are a bunch of proxies and tunnels that add headers, and you don't know, because of course, if you're here and there are all these other intermediaries that are just adding header to your request until it gets the server, the actual complete header is not clear to you. So with this, you can say, hey, can you send me back whatever you have seen so far, so you can actually figure out if somebody is doing something. But of course, this has to be honored by the server. And connect is a method that is used with proxies to connect to proxies. Resources can be specified by an absolute URI, okay? Or sometimes when you're talking to a proxy, instead of specifying an absolute path, so only this, you also have to specify the exact host that you want to connect to, because of course the proxy doesn't know, where to connect to. So you usually request a complete URI, and then the proxy will ask just the path resource on your behalf and send it back to you. Of course, if you connect to a server that owns that resource, then you use simply the path. So this is a very simple request example. Interesting, there is this carriage return line feed. That's how you determine that the header is over. You can see, the various fields, dates, don't cache the result. The referrer usually is the page that contained the link that you click to go there. And the referrer is very useful in security applications, and actually being able to analyze this can give you an idea, for example, of what pages have caused you to go to a certain file or to a certain malicious page in some cases. And you can have things like say, oh, give me this only if it has been modified after October of some time. And of course, you can notice that there is a host field right there that specifies, in this case, a host and a port. And that's because in HTTP 1.0, you could not do that. So you could only have one web server per IP address. But of course, people say, this is crazy. I want to run 150 web servers on one host, on one IP address. So whenever there is a connection to port 80, if you have 150 different websites, which is the site that you are referring to, right? So imagine a hosting company like, GoDaddy or this big hosting company. They also host your website. How do they know? They have one host with hundreds, if not thousands of websites. When a request comes in, the only way to know which is the website you want to talk to is through the host parameter, and that's how it's specified. So that is actually required. Replies in HTTP, again, are a header, carriage return line feed, and then a body. The header contains the protocol version, status code, some text, and then headers that are, again, some general headers, something that is, that affects the response, and something that is relevant to the entity that is returned. And again, the body is considered a byte stream. So it could be binary, it doesn't have to be ASCII. Status code, you're very familiar with probably the 200 code. That means you did okay, success, and the 400 code, with most famously the 404. That means I don't know what you're talking about. There is no such resource. And the 500 is server error. Interesting, also the 300 codes are for redirection. That means that you ask for a resource and you will get a reply that, for example, tells you, hey, these resources have been moved. You're looking for, slash shopping slash cart. You can do a redirect to slash shopping slash cart 2 because you just create a new cart and you want to automatically redirect people to that new page. Most browsers will take this 300 code and automatically go directly to that page. So it's interesting. You would think that this is actually a very harmless thing, but we did a whole research on execution after redirect because people don't understand how redirect works, and this can introduce major vulnerabilities in web applications. And we will talk about it at the end of the web vulnerability part. Okay, and of course you also have the 500. It means that the server had some problems, but also that the service is down or something else. And we're talking about 404. Interesting is the 401 and 403, especially as you will see in authentication, those 400 come very handy. So these are reply example. You can see there are headers. There is this protocol 200, everything well, okay, just a string. Then you have a bunch of headers and the actual code. In this case, is the HTML code of a page, but could be fundamentally anything. Note that the content type is specified in one of the entity headers. So again, we have general header fields in both request and replies. These are just something that has to do with the request. So for example, a date or the way in which we encode our transfer. Then we have request or response specific header fields. For example, the host, if modified since are a good example, or user agent. And then entity header fields. So for example, how the content length of the particular entity they were giving to you. As you will see, that's an important field that gets misused a lot. Yes?
I've heard I think it's the refer field is
misspelled.
What's that?
Misspelled.
But can that be used to track people? And if so, can you set it to null and not break stuff?
In theory, that's a good question. In theory, you cannot set, unless you hack your browser fundamentally, you cannot modify your refer field. It's included automatically by your browser when you do it. Of course, you can put a proxy and do whatever you want with your requests. You can modify them, take things. I don't think that things would break necessarily. But it depends on the application. If an application that actually relies on that, for example, to determine where you're going with a particular request or where you're coming from, then you're going to break stuff. But in general, that can definitely be problematic. One thing, for example, in malware, oftentimes those fields are sort of manipulated or removed in order to prevent people from tracking, or to give people the wrong idea of where a request comes from. Because if the refer is www.microsoft.com, some security mechanism might decide that is actually okay. But all right, let's look at the basic HTTP authentication system. Works as a challenge response system. Fundamentally, when you ask something that is protected by some authentication, you will get back a response that is a 401 error. And that's when your browser pops up something, say, hey, provide username and password for this realm, so this particular set of pages that are identified by a specific path. And then you have an authorization field that provides the required credentials. The interesting thing, and this has caused a problem in the past, is that the authorization is actually base 64 encoded and is username and password. Oftentimes, this has caused people to believe that this was encrypted. It's not encrypted, it's encoded. So HTTP vanilla authentication, you can totally sniff your password. They will just have to decode base 64. Okay, so you can see here that the 401 will say, hey, you have to authenticate before you can receive this. The realm, which would be this subset of pages, is this one. So you can go in your own personal database, say, oh, for that realm, reserved docs, I have this username and password. You put it in, and you are accessed. In HTTP 1.1, they put together a better system in which you have a nonce and you have to provide something that is, the encryption of that nonce plus your password and so forth. But of course, this also requires that the server has to have access to hashes of usernames and passwords. Another important technology is HTML. We're not going to talk, extensively about HTML because you all saw it a million times. It has a long story from 1995 in HTML 2.0 to something that was as recent as October 2017, the latest recommendation for HTML 5.1. HTML has evolved immensely. Now it has, interframe message passing communication system, native handling of objects, and with complexity comes also the potential for vulnerability. The basic idea, of course, so you have start tags, end tags, self-closing tags, void tags that are just self-contained, and tags are hierarchical. And you might say, why you tell us this? This is actually interesting because there are a number of attacks that only focus on the parsing of the HTML. Because if I can, for example, confuse a parser and consider a close tag not a close tag, I might inject some JavaScript that would be otherwise removed, for example, as you will see. So understanding how HTML works is important. This is a super simple example, which is hierarchical. So you can see that there is actually a tree with the HTML, head and body, title, content, and a paragraph with example text. So tags can be in 4 different syntax. You don't see this that often. We're more used to that. But you can always have something that has an attribute that is just a name. You can have an attribute that is set to a specific value. Of course, you can have single quote, double quote. This also can be used to confuse a parser. Suddenly you insert a quote in something that is used to create HTML, and suddenly you can influence how people decide when a tag is over. And since these elements are actually used by the browser to create different contexts in which different things can happen, confusing the browser and the browser parsing is actually an attack technique. And of course, you can have multiple attributes. You just separate by space. Just to mention, and we will see, there are also simple attacks where having just the same attribute multiple times can confuse an application and cause a vulnerability. Our best friend in the attributes or the tags is the anchor tag that can have the hyperlink reference, href, with a specific host, and that's how we create hypertext. So you can have your basic HTML 5.1 page or 5 page. Interesting, there are also character references. So if you want to specify characters in a web page, you have multiple capabilities. And these are mentioned because also this can cause, if a browser is not done right, can cause confusion in the parsing and cause problems. There are scientific paper that researched the implementation on how these character classes are parsed and found several problems that would cause, for example, certain characters to be parsed into binary code that then ended up being exploitable. So you can have something that is a named character reference like AMP for the ampersand. You can have decimal Unicode by specifying the pound sign, or a hexadecimal Unicode specifying the X sign. Okay? Do you guys know, who doesn't know what Unicode is? You don't know what Unicode is? Oh God, I found one thing that Fish doesn't know. This is a magic moment in my career. That's great. All right, since everybody knows what Unicode is, Hojat, what is Unicode? That's very good. Close. And so what is, for example, UTF-8? Anybody knows the difference between UTF-8? Yeah? Correct. One is the encoding, one is the representation. So Unicode is fundamentally a large space that says that number 32,517 is a weird Greek letter. So fundamentally, every single every single type of character in every single language. Also, you can have, weird chess pieces. Imagine everything that you can imagine is a Unicode character that is a specific number. And then you have to represent this somehow. So you can use UTF-8, which is a representation that has the advantage that ASCII code has the same representation of Unicode. So ASCII code is a 7-bit code. So in ASCII, you have 7-bit, to represent fundamentally the, what we know as the ASCII code, A to Z, etc., etc. And then so then it's been extended with, to take advantage of the other 127 characters. And eventually people decided that was not even enough. So they went to Unicode, that is this complete description or a very extensible and extensive category of all this thing. At a certain point, you have a Unicode character, you have to decide how to represent it in terms of the bytes. And so UTF-8, UTF-16, and others are just a way to take that number, 32,517, and decided how to encode it. There was one and then two. Yes?
So is Unicode basically just like ASCII on steroids?
I like that, yes. Just with a very big space. I think that initially the space for Unicode, and now I don't remember, it was FF, and then they move it to, but don't take my word, you have to check, something like 10FF. So you can have this many characters for Unicode. That's a lot of characters.
Is it like extensible? Like if you wanted to create like add, I don't know, emojis or something, can you tell the computer to use, two Unicode characters and
No.
two of them as one?
Not that I know of, but I know that continuously not all these numbers have been assigned. So my understanding, and now we're getting into crazy typography thing, my understanding is that they continuously add to this thing new characters, the emojis or things like that, and then you can use them. But you will see the classic when you have something that is not being recognized by your current display. It recognizes that it's a Unicode 55,615. I was like, I don't know the mapping to that, so I'm going to put a nice weird thing. There was 1 and 2.
So piggybacking off of that, that's how emojis are encoded in Unicode, or is there some extra representation or something?
That I don't know. Yes.
So I know there's UTF-8 and 16. I think there's also UTF-8 30 or UTF-32.
Correct.
That's 4 billion characters. Like realistically, what would you ever need 32 bits to encode?
Klingon. Yeah, lots of emojis. Different types of poop emoji. I think that people really like that emoji, so there are many different versions. All right, anyway, the interesting thing, and you say, why are you telling this? Even this has security implications. For example, people use weird characters that look like real characters. For example, I think there is a Russian character that looks like E or A, but actually are not that character. And so you can have something that looks like Facebook, but is actually a complete different weird set of Unicode characters. So it looks like Facebook, but is not that string. And you can see that this can be confusing for thing. Actually, there are websites where you can go and you can put any string and it will create this crazy version of whatever you write in plain English using all these different characters. It's actually incredibly amusing. I strongly suggest that you go find it. But this can cause all sorts of problems, especially because sometimes you can combine this with the fact that certain things are read from left to right or right to left and can cause other implications from the security point of view. And we will see example as that. So these are examples. You can see, the named thing. You can do the decimal, hexadecimal, or extended hexadecimal. Very simple. And you, of course, can also represent the same thing in many different ways. Also, this is the less than character. It can be many different things, and you can see that this can cause all sorts of problem in parsing. But these are just plain example. Before we break, I want to talk about forms. Forms are a very important part. They really bootstrapped the interactive part of HTML. So if you think historically, first the web was this hypertext thing that allowed people to browse and say, oh, I want to see the paper of this guy, and you go to his website. I want to see the result of this guy, and you go to his website. So think about the web was really a way to share and interconnect scientific results at the CERN in Geneva. But then for example, one thing that people realize, say, I might want to submit data. Okay? Form is a way to collect data and send it somewhere. There is an action attribute that specifies where you're going to send, so which URL you're gonna use to submit. There is a method that specifies if you're going to use a get or a post. We will see what the difference is. And within a form tag, you can put a bunch of input tags that allow you to get information. Some of them could be explicit, some of them could be hidden, we will see. When you press submit, if you have a get method, the data is put together in the URL, in the query path, and sent. If you have a post method, it's put in the body instead. So usually the rule is that get request should be used to obtain fundamentally idempotent resources. So if you do get twice, you are just obtaining something, parameters or not. You're not modifying something. Post should be used for something that is actually data submission. Of course, do people abuse this in the worst possible ways? Of course, there are entire things that use get because it's simple to submit values, and they use post to request information. But those are semantically different thing. Also, data is encoded in either application form encoded or multi-part form data. Get, always use the first one. We'll see what it means. And post depends, can use one or the other. Okay. The multi-part form data, important, is used to, for example, upload large files and things like that. So the data is sent as value and name pair. So you can have an input tag. You've probably done this a million times. Say this is a text file. His name is foo. The value, if you have a value set when the form creates as a default, that's great. And the value is tagged either to what is set already or what the user put in. And then, if nothing is present, it's just an empty string. The name value pairs are encoded, and fundamentally spaces are translated to the sign plus instead of just being encoded as %20, and multiple name value pairs are separated by ampersand. This is an example. You can see this is a form. The action is the URL. In this case, the method is get, even though I don't see it. That's the default, I guess. And the resulting URL is like this. You can see that spaces have been substituted with pluses, and ampersand divides the different fields. Why I tell you this? Once again, this can cause all sorts of problems when parsing username and value. If you can, for example, submit something that makes an ampersand appear magically here, you can start changing the match or the mapping between attributes and values. Yes?
And how are these requests authenticated? Like if I wanted to change, John Doe to my name or something?
They're not. I mean, this is the value that you provide. As we will see, we will see when we talk about sessions, there is a concept of HTTP is very cool because it's stateless. So you ask something, you get something, that's it. And then the next time you come, you ask a new request. Yeah, you can have multiple requests in a single connection, but if you look at the basic concept, it's a stateless protocol. And now, stateless is not always good. For example, I want to know that you're having a session at Amazon and you are who you are and your cart has all this stuff that you bought. And so I have to remember the next time you show that you are that person. As you will see, there are a number of ways to keep track of that. The most common is using cookies. That's how you remember who has been. So here you see the form in URL encoded. In this case, the method is post, and this is the request. Instead of having the parameter passed on the command line, you can see there is a contact length, and then in the body, you have the content submitted. And I'm going to stop exactly here. We're going to take 10 minutes break. So we're going to start talking about HTML frames. Frames were introduced pretty early in the design of the web or design of HTML to represent a page with sort of different subpage. The basic idea was to show banners or navigation elements. Of course, nowadays we do everything with CSS, but since there's still support, it's nice to know how they work. They can work as a frame set where you have a tag, the say frame set, and within the frame set you can have different frames, and fundamentally it looks as ugly as you can expect. Everybody hated frames from the get-go because it would desynchronize navigation, but at a certain point it was the only way in which you could set up things. So don't look at this, but mostly, this is one frame and this is a completely different frame. And this is loaded from a different source. More famous or infamous is the iframe concept, because this does not require a frame set. It's just one tag. And what happens, this tag causes the loading of a page within its own frame. Why is this infamous? Because fundamentally, if you're able to inject an iframe in a page, whoever visits a certain page will also visit automatically the page in the iframe. So a lot of sort of drive-by download attacks are done that way. Somebody breaks into a legitimate website and injects an iframe that is invisible because has zero size. So when you visit this benign page, your browser to load that iframe automatically without your permission or without asking you if you should do so, will also visit the malicious one, which will send some JavaScript attack and compromise your browser. So that's why it's important. An important thing that it's part of the HTTP and the web is maintaining state between different transactions. HTTP, as we said before, is a fundamentally static protocol. So there are different ways in which you can sort of try to remember if two HTTP requests are connected. And historically, it has been done in a number of ways. Some of them were good ideas, some of them dumb, as we will see in a second. But the basic idea is that somebody wants to know that you are the same person that came 3 or 4 requests before. As we will see, you can do this in a number of ways. You can modify URL, you can do hidden forms, but nowadays, fundamentally, it's used with sessions and cookies. One thing that you can do, and that was done by some tool, is to actually rewrite pages. So imagine that you ask for a certain request, and I take the page, the HTML page that I will send to you, I take every single link, and I add to that link a piece of information so that if you click on that link, you will send that information back to me. Okay? So in this case, the client is asking, for example, for a login with a username and password, and the server, customized the HTML so whenever every single URL has this information added. That means that you will have the catalog, you press on the link catalog, and automatically you will convey back to the server this additional information that you're user-full. And that's just a way to keep track of who you are. Another thing you can do is to use input hidden field in forms. So whenever I send you something, I add some hidden information that tells me, for example, that you're user foo. And so whenever you, for example, submit any form for a catalog, in addition to the field that you actually see, like a submit button or other information that you insert, the user equal foo element is returned with the post request or get request, whatever that is. Okay. Once again, it's a way for the server to customize what content is sent to you so that when you act on that content, you send back the additional information. But of course, the way in which it's done today is through cookies. Cookies is a mechanism that fundamentally says during a transaction, a server can send a header that asks the browser to set a cookie, which is storing a small piece of information that, it's just fundamentally a variable name and a variable value. And then it's the task of the browser, whenever they go to the same website or the same website, you can also specify a certain subpath and so forth, the browser adds the cookie header to the request. And by doing this, it's very similar to the other situation. You have a way in which you can send information back and forth to track information. And of course, cookies can, encode everything, user preferences, status of, multi-step processes like your cart. Fundamentally, you can put anything, up to a certain size in your cookie. And also, sessions are used for authentication. We've seen an example with PHP. And of course, cookies are accessible only from the site that set them. So if you are at website, foo.com, you cannot access the cookies set by bankofamerica.com because, of course, that would be a gigantic security violation because you could steal, for example, a session and initiate a different session. If you look at the structure, very simple, name equal value. There is an expiration, the set of resources, so under which this cookie should be served. So you can say if you're requesting anything under /catalog /acme, then send this particular cookie. You can specify a domain. Important, there are two flags, secure and HTTP only. Secure makes sure that the cookie gets sent only on an SSL protected channel so that you avoid by mistake to send a cookie over plain HTTP. And HTTP only prevents client-side scripting from accessing the cookie directly. So as we will see, there are two things. There are the document object model and the browser object model, and which are the basis of any modern application. And in the browser document object model, you can actually ask for the cookie for that document. And by doing that, you could actually, if you are executing, as we will see, malicious JavaScript, leak this information to a third party. By specifying HTTP only, you make sure that the cookie is not accessible to JavaScript. So even if somebody is able to inject malicious JavaScript in your website, they will not be able to access to that sensitive information. And of course, cookies are the basis for sessions. But sessions are, of course, something that goes beyond cookies. We have seen that we use all these different techniques to maintain state. And of course, since we use those techniques to maintain states across HTTP requests, sessions, which is maintenance of state, can use all of them. Most of the time, as you will see, we use cookies because they're the simplest way that everybody understands well. But the basic idea of the session is that whenever you connect, you authenticate, you generate a very long and unique session identifier, and then every time you come back, that's the only information that I use in order to identify you. And we will see examples of how you do it and what's needed to do it right. Let's talk now about how to execute code on the server side. The most important thing that we will see is the ability to sort of customize the code that is sent back to the request. And the first way in which this was happening was through the common gateway interface. And this is now an obsolete way, if you want, to execute back-end programs and extend web servers beyond just serving documents. But this one thing changed the internet completely, okay, or the web completely. Because when HTTP and HTML were introduced, it was a cool thing. We had images, nice-looking documents, and hypertext. But it's when the CGI standard was introduced that you could, because of a HTTP request, execute an external program, for example, access to a database, a program that would go in a bibliographic legacy storage and find information, and all that stuff could be returned back. So it was that first one mechanism that made possible to make HTML and HTTP the glue that would bring to users all these different databases that were set up across the internet. So suddenly, thanks to CGI, you can do, you know, all sorts of cool stuff. You can, of course, use the CGI interface in two ways, using a URL with the get method, okay? And the advantage of this is that, of course, by doing this, you have a static URL that you can actually store in a sort of as a link. Or you can actually use the post method with the advantage that the input parameters can be as big as you want. And usually, every website has a path that is not a real path. There might be no CGI-bin directory. There is just a path that says, okay, this is a website. If you see this path, what comes after is a program. In this case, prg.exe. And then there is, you know, something that very seldom you see called extra information. And then you have the parameters, or you have the parameters in the body as they're passed. And the server and the CGI program interact by using environmental variables, okay? So a CGI program can actually be written in any program you want. It can be an executable, can be a Perl script, can be a Python script, a PHP script. But the basic idea is that everything that is sent as an input, for example, if you do a post of a large file, that large file is going to send to the standard input of that program that is executed. And all this other information is passed as environment variable. The method that was used, that path info after the program and before the question mark, the actual query string, content type, content length, and a bunch of HTTP field. And here you can see that, you know, there are a bunch of variables that are set up, you know, what remote host, you know, invoke this method, and so forth. So this is the basic way. Of course, soon Microsoft says, oh, we can do better, and we will make sure that we are completely incompatible. So they create the active server pages. Yes?
When a program that you call the CGI,
yes.
Does it return HTML, or does it return stuff to the server that goes to...
Very good. Very good question. Whatever is returned by the program is the server returns some of the header, and the program is responsible for returning sort of like the content type and the size of the content size. But in theory, even if the program just returned random stuff, the server, depending on the server implementation, will take that stuff, add some headers, and send it back. So some, if I remember correctly, I wrote last CGI program a long time ago, but Apache would complain if you don't print a content type because they want to know what type of encoding they can do. Also, they cannot force you, for example, to send a content size because you could be a streaming application. And so you do a request, and I start sending you data as a CGI program, and I don't know how big it will be until I'm done. Okay. Other questions? So active servers pages, they're very similar to CGI script, but to make it user-friendly, actually have a mix of text, HTML tags, scripting directory, and we will see server-side includes. And fundamentally, these are things that whenever the page is retrieved, the text stuff stays the same. It's HTML, but all these directives are executed and can make the page more interesting, can execute code. And so this is an example, something that, say, obtain something, a variable name from the query string, and if somebody passed actually the parameter name, then the response will be, hello, welcome, or we will complain if nothing is provided. Another way to execute server on the codes on the server side are servlets or Java server pages. These are technology that are used more than you might expect in the industry. These are actually sort of Java programs that are executed on the server side to answer requests. The advantage that many industrial applications see in this is that Java is it's a type-safe program that has more security feature, more controls, and therefore builds more robust application compared, for example, to PHP, which is very prone, since it's an interpreted language, to have all sorts of problems from that point of view. Of course, Java server pages are a mix of stuff that looks like scripting directives with static pages, and what usually happens is the Java server pages are actually translated into servlets and served by a technology like Apache Tomcat and something like that. Another super popular server-side scripting technique is PHP. You probably all use PHP. It was made actually particularly popular by the LAMP stack, which was Linux, Apache, MySQL, and PHP all together to provide an efficient server, easy to write language with a backend database together on a pretty solid platform, and has been incredibly popular ever since. You probably have seen a ton of PHP. PHP can be standalone or can be included as a tag within your HTML, and fundamentally it extracts, for example, parameter for post, and can open file, write to file, and include external files as well. So it was born with in order to be easy to use for developers. They wanted to get the market, get people to use the code, and so they created a lot of mechanisms to make it absolutely easy to create website in a minute, but as we will see, some of these techniques backfired because they became huge security holes. And of course, nowadays, a lot of the development is done with frameworks like Ruby on Rails or Flask. So these are environments that provide you with a lot of sort of like piping and infrastructure so that you can focus exclusively on the logic of the application, and you don't have to waste a lot of time to do a lot of the work that normally a web application has to do. For example, one thing that is very cool is the ability for some of this to store and read objects from the database without having to do actual query. You just map the actual object to the database that fundamentally acts as a persistency layer. And so these have become incredibly popular. And this is a very recent analysis. There's somebody who keeps track on what frameworks are most used on the internet. And PHP right now is around 25%. J2EE, another 10%. If you look to Ruby on Rails, between this and this, another 10%. But you see that there are then a bunch of other minor framework that are used all over. There is somebody who crawls the internet and find out about all this. But you see that stuff like ASP.NET still has a pretty substantial size of the market. User agents, of course, are your browsers, and they're the one that you use for resources. wget, curl are command line ones that are super useful when you're doing some hacking. Of course, you have the classic browsers. And as you will see, some user agents support the execution of code. Usually the command line one don't. And so, for example, if you're doing some analysis of a website, it's much better to use tools like Selenium, for example, which are tools that drive one of these browsers, like using scripting technology, so that you can actually get the actual browser to go to a page. And actually, I spent my Sunday doing exactly that because I had to go to the recruitment website for, you see, recruitment. We have to hire people in computer science. And I had to do some analysis. And of course, everything is just web. And I would have to click on a million links in order to identify what I had to do. So I took Selenium, I took the Chrome WebDriver, and I just wrote a Python script that goes to the website. And then when you're redirected for authentication, the browser just does the right thing. So you can say, oh, in this form, insert this name, this password, and so you can automate all sorts of script. Of course, my case is a little corner case, but this type of technology like Selenium are used for quality assurance and website testing, and they're incredibly useful. You can set them up in 10 minutes, and they will change the way in which you see interactions with web application, especially when you have to execute Java code, because there are, in some cases, when you're doing some security analysis, there must be some Java code that will only execute correctly if you're running in a browser that is a real browser. Why? Because A, it might use some idiosyncrasy of that particular dialect of JavaScript, or B, because the browser object model, so the sort of abstraction that is provided to JavaScript to modify the browser behavior is only truly available in the browser itself. In terms of executing code on the client side, we have the Java applets. You might not remember that, or you might not have ever seen a Java applet, but these were all the rage in the 90s. This was like, everybody was excited because it was this idea that you don't have applications on your laptop. You just download these applets in your browser, and they run as an application, and when you're finished using them, you throw them away. And so you always have the most updated version of the code, and everybody went crazy, and everybody was in the security community was like, oh, but this is crazy. You're getting code for somebody, and you're executing. So, and that's where, when Java applets were introduced, that's when sandboxing became a very important problem. Because you have this code, you cannot make any assumption on this code. It could be anything. So you have to have something that prevents this code from just getting on your computer and stealing your files, destroying your files, or whatever, killing your computer. And so there was a lot of research that went into sandboxing mechanisms. And all this research eventually became JavaScript related because the Java applet mechanism was not it was not embedded enough with the surrounding page. It was very much you download a thing and you have a little container in which you run a program, and so you have a little video game, but nothing that could actually interact with what was happening in the page in a meaningful fashion. And so it never got adopted widely. Something that got adopted widely and was at least responsible for a lot of security problems were ActiveX controls. This was like sort of the Microsoft response to Java applets, but they said, we don't want Java because it goes too slow. At that time, in the 90s, having an interpreted language like Java within a browser with the current infrastructure was not sufficient. It was, everything was very slow. You could not do real application. So ActiveX are actually, they're binaries. They're signed. So only providers of, trustworthy software can run this, can install these binaries on your machine. And then when a page arrives, the page can say, oh, I would like to have that particular ActiveX control. Maybe is an interface to a database. You have it pre-installed on your machine. The ActiveX control is executed, and now it runs not in a sandbox, but with full privilege of your application. So because of that, Microsoft made sure that no bad guys could actually inject ActiveX control. So the bad guys could not say, oh, here an ActiveX control like you would send a Java applet, because they would run as if it were the browser. Now, what they didn't really realize is now they have all these ActiveX control, and this is not perfect software. So a lot of the drive-by attacks that would compromise your Windows machine was fundamentally, oh, give me that ActiveX control foobar in which I found a vulnerability, and now I can pass parameters to this ActiveX control. I do a buffer overflow, and now I'm executing code as the browser. Means that I have full access to your interface. So ActiveX control as a mechanism per se was not, in most cases, what was flawed. What was flawed is that the surrounding code could instantiate this ActiveX object and pass parameter that would break the security of the object and cause a browser compromise. And in fact, in the latter version of the Microsoft Edge browser, ActiveX control are not supported. And of course, we could not talk about client-side scripting if we talk about ECMAScript, JScript, JavaScript, VBScript, call it whatever you want. If you know ECMAScript is like the name for the standard, then Netscape call it JavaScript. Of course, Microsoft call it JScript. There is a version based on Visual Basic that is called VBScript. But that's a basic identical concept. It's JavaScript code. Again, worst name ever because it has nothing to do with Java. But it tells you how excited everybody was about Java when Java came out. When it came out, it was a revolution. Just the fact that you could compile Java bytecode and then execute it on different platforms without having to recompile. People are like, this is incredible. So we have a scripting language. How do we call it? Scriptable? ECMAScript? No, let's use JavaScript. Nothing to do with Java whatsoever. The name stuck, and today we still have this kind of thing. So the interesting thing is with JavaScript, you can have JavaScript code in two ways. You can include an external source. So I say, this is a script, this is a URL, go get the code, put it in this page, sort of inline it and execute it. Or you can actually put the code within a script tag in the browser and have the code execute when the page is rendered. So JavaScript was very cool, but what was super cool was the document object model and the browser object model. As you will see, JavaScript plus the DOM and the BOM plus XML RPC is what actually created the applications that we use today, like Google Docs, Google Sheets, Facebook, all these interactive applications that actually implement the model that the people that came up with Java applets wanted in the first place. It just that it was the wrong technology. Instead, the cool thing is here, through JavaScript, you can modify the document itself. So the document object model allows you actually with a script to modify the structure of the document. So the document, as we will see with XML, is fundamentally a tree of elements. Well, you can, for example, find an element using an ID, create an element, for example, in a horizontal line, and then you can say, oh, append a child to this document, and suddenly you will see in your web page a line appear whenever the code is executed. Okay? So this, before we had this type of behavior, fundamentally, people were using times and iframe and reloads in order to create some fake communication and fundamentally refresh your page and give you the idea that there was actually an animation. Now, the cool thing is that thank you to this thing, your page can be modified without having to reload the page again. And so, for example, you can have something that goes say, oh, I have a new messages on Gmail. Yes, well, then create another little div element that represents the message. Thank you to the document object model. And of course, you have also the browser object model, which allows you to access information about the browser itself, like cookies, like the location, like the history, and things like that. Of course, you can see that since JavaScript is doing so many things, there are a lot of security issues. So fundamentally, there is a first major security issue is sandboxing. So given that I am executing some code, I want to make absolutely sure that this code cannot do stuff that I don't want it to do. So there is no access to files, to networking resources. You cannot create a window that is smaller than a certain amount. You don't have access to the browser history. Okay? And in fact, for example, a lot of attacks are privacy disclosing attacks that use all kinds of subterfuges in order to find out where you have been. For example, one classic attack was to render a page. If I want to, for example, I want to find out if you have been to, I don't know, I don't know, it's a compromising website. ilikecats.com, extremely compromising. If I want to know you've been there, one thing that people would do, they would create a web page with that link, and the browser, if you already visited a web page, will make that link red because you already touched, or purple because you already visited once, so it would render the way. The page itself would check the color of the link, find that it's purple, and now a page that doesn't have access to your history knows that you visited that site. And this is just an example. I mean, they came up with, incredibly sophisticated way to find out what your history is. Because if they can find out your history, there are many things they can do. They can identify websites that are good candidates for cross-site request forgery. If I know that you often go to wellsfargo.com, you're the perfect target for my cross-site request forgery attack that will transfer money from your bank account to mine. If I know that you have been to certain sites, I can sell the information on various platforms. And so this has become kind of a big deal. So sandboxing. We have to limit the code to do only specific things. But not only, we also have to, one important thing is the same origin policy. So as part of this sandboxing, not only I cannot access the underlying environment, but when I get some JavaScript, I cannot access resources that are associated with a different site. Obviously cookies, but everything else. Suppose that I have two tabs on my browser, and I have this evil.com JavaScript that can see the other tab that is, for example, the login to Facebook. I could go modify the form using the document object model and make it that when you put your username and password, you send me, the bad guy, the credentials instead of sending them to Facebook. So the JavaScript model makes sure that everybody can only operate on the resources that are part of that website. And one of the most common attacks that we will see in detail, the cross-site scripting attack, exactly tries to bypass this limitation. I think this was pioneered by Firefox. You can have signed script policies where you actually sign the script, and therefore they can have more access to the environment, but that's not very common nowadays. And also you can specify, you can have a configurable policy that you set in a separate file if you often visit specific thing. Nowadays, this is mostly due with content security policies that, as we will see, allows you to do certain specific things. So fundamentally, as we said, every frame in the same origin policy, every frame has its own environment that is determined by the server protocol import from which the frame contents were loaded. And so you cannot see anything else other than what was set up by that fly, including cookie. Of course, if you include external code, that code will be executed within your same policy. And this is incredibly important, okay? We actually did some research exactly on this to understand who are including what. Because imagine that we have a very, critical website like Cottage Hospital in Santa Barbara. And their website say, oh, there is this great widget in JavaScript that allows me to check how many days, you will be before some event happen. And so they decide to include, using a source tag into their website, that JavaScript code. And let's say that, that JavaScript code comes from coolgadgets.com. Now, if somebody breaks into coolgadgets.com and is able to put some malicious code into that particular gadget that is included by the hospital, when you go to the web page of the hospital, you will execute that code in the content of the hospital. So we'll have access to your personal information, your health information, everything that code can execute. And even this is incredibly simple as a concept. It's an enormous source of problem. Because fundamentally, the moment you include outside code, your security is as good as the one of this bar.com website. So we did actually a study of the internet, and we would say, okay, these are top Alexa websites, okay? And they have links to external websites. So how is the security of these other websites? And so we went in, we tried to determine by using a number of heuristics, and we found out that very critical, high-level websites were depending on the security of incredibly crappy sites. And so if somebody would break on those, they would be able to compromise the security of the good ones. Not only. What do you think it happens when bar.com does not exist because it went out of business? Nothing. There is no code to be loaded, so that dies silently. Until you decide to register a name bar.com and you start serving, script.js. Now you have full access to that particular server, and you can serve malicious JavaScript with the privilege of Bank of America, Cottage Hospital, whatever that is. I doubt that there is a bank that does this, but no, that would be really bad. But this is important to understand. If you include something in your JavaScript, this runs as yourself. We're going to take a 10-minute break, and I'll see you at 2 o'clock. So let's talk about AJAX, which stands for Asynchronous JavaScript and XML. And fundamentally is a combination of technologies, JavaScript to actually execute the code on the client side, plus the DOM interface to manipulate, combined with the last piece that we need, which is the capability to make asynchronous requests, RPC-like requests to the outside world. And this is important because in a way, if you think about it, before the introduction of this, the only event that could trigger a new request was fundamentally a reload or the clicking on a link. Now, we have a mechanism that completely unbeknownst to us can go to a website, download some content, and show it to you. That's why you can have those beautiful rotating ads on your web page and all these other amusements on the internet. But also you have Gmail and all these web-based applications. So this is really, I would say, it has been the thing that made web applications actually usable, and in a way, then combined with the rise of the cloud, the fact that we want everything on our website at this point or stored somewhere, let's say, has created the world we live in, where most people, don't even have actually file on the file system. So all this is based on the concept of the XML HTTP request, which allows for asynchronous execution of request. Okay, and fundamentally, the idea is that you request the execution of a callback every time a certain request changes in its state, and then the request can say, hey, open a certain file, and you can see that the request is asynchronous, true here. They say that the execution of JavaScript is completely independent. So it will happen as the resource is downloaded. And then fundamentally, the whole request that has been triggered goes through a series of state. So from 0 to 1 to 2 to 3 and so forth. And every time the state changes, that function callback that has been set is invoked. Okay? So fundamentally, your thing could have something that say, oh, if your ready state is equal to 4, then I received all my data, do something, create the message window with the message you just retrieved. Otherwise, just skip and wait for the next to go on. So this code will be called with 0, with 1, with 2, with 3, and then once the object is complete, you will execute your code. Of course, you can also, have some code associated with loading, and then you want to put the spinning wheel of death on front of your information, whatever you want. After you get this, of course, you use the document interface, the DOM, to modify the content. You can have the content that you retrieve as actual text, or you can actually get your response as XML, and in that case, you can use the DOM interface to modify. So this brings you to the state of the art in terms of techniques that we have to keep state. I haven't mentioned two things in keep state that I was partial to it. I almost included and then decided not to. One is Flash cookies, and I just want to mention Flash is another technology for client-side execution of code. If you want, it's almost similar to a Java applet. It has been riddled with so many vulnerabilities that now it's slowly being phased out, and it looks like it will not be used anymore. It's a proprietary format from Adobe. It's not an open technology. And Flash has a way of storing cookie that is proprietary, and the main advantage, it follows fundamentally the same mechanism of normal cookies, but it can store a lot more data. So the storage is much more substantial. The other thing that I haven't talked about is how people are using tracking, which is more of a security attack. But that's more of a privacy violation, and it would make the whole thing explode. Instead, now we're going to switch to the actual web attacks and how they work. We will see attacks against the authentication process in web applications, authorization. We will see common injection, unauthorized access, man-in-the-middle attack, and also some attacks against the HTTP protocol implementation. So the actual components that pass HTTP protocol back and forth. Let's start with the tools. First of all, when you're exploring vulnerabilities in web application, you need a good way to monitor what the traffic is. And not of course, you can always sniff the traffic with TCP dump. Now you're all expert sniffer writers. But actually, you can look at other things, of course, logs of web servers and things like that. But one of the most useful tools that you will have to use extensively in homework 4 is client-side proxy. This is something that you put in front of your browser. So every time you go to a web page, you actually talk to this intermediate step. And this will then, if you can interact with a user interface with the actual web proxy, you can, for example, modify parameters. You can see exactly what is being sent as what is being received. And this is useful for a number of reasons. For example, it's useful to see what gets received because the code that you receive might actually modify the document. So if you receive something and you simply use the developer mode, for example, in Chrome to look at the code might already have been modified. Maybe there was some parts that have been removed and used for something. So it's only by really seeing what gets transferred between client and server that you can be sure of what goes on. And sincerely, it's very interesting to act as an intermediary and go to websites like CNN, Facebook, this very big website, because you will see how many moving parts there are, in terms of the ads, in terms of the different frames and the layers and everything else. It's just a learning experience. I love a tool called Burp, not the greatest name, but it's really a good tool that it's available for non-commercial use in limited form. If you actually buy the thing, it's not super expensive. I think it's like $250. But if you're a web pen tester, I know for professionals, it's not very expensive compared to IDA Pro that is like, can cost you $6,000 if you want all the bells and whistles or something like that. But it's an incredibly useful tool. There are also a lot of tools that are plugins in your browser, both for Chrome and for Firefox, that do fundamentally the same thing. They're also very useful. I prefer, and this is just my personal preference, an external tool and not something embedded in the browser, just because it gives me absolute confidence that what I see is the network interaction between the two. The extension could be, in some way affected by the code, and depending on what you're pen testing, could be an advantage or a disadvantage. But you need a tool like that. Just don't look at the page because you might miss out on something. If we look at authentication, there are many ways in which you can authenticate, where you can use, we'll see IP address, HTTP-based authentication, and other things like that. Of course, some of them are stupid, like IP address-based authentication. I hope that at this point in the class you realize is completely ridiculous. IP addresses, can be shared behind a NAT. The same user can have different IP address because of the HTTP and things like that. So I put it here fundamentally for our amusement. HTTP-based, so using actually the digest, will work for very basic things, but it will not scale. So if you want to share, your pictures with a friend, say, hey, I put it there. The password is pictures, and no, the name is picture. The password is, dog23. That's fine. But as a real authentication system, it's not something that works. So one option is to actually use SSL and have a client-side certificate. The problem is that very few people have client-side certificates. So unless you are a government agency and you want to create super secure communication, that's not your way. And so form-based or some form of form-based authentication has been, for many, many years, the fundamental way in which we authenticate to applications. And now, of course, with single sign-on and third-party authentication becoming more common, we're all moving in that direction. In the basic form of authentication, the form is sent to use usually username and password, whatever your authentication is. The application verifies the credential and sends you back a cookie that in some way, you know, in this case, it sends you the actual username and password to you. And then every time you come back, you will reprovide this and you will not have to authenticate every time. Now, this is, of course, there are a number of problems with this schema, okay? So, first of all, authenticators should not have predictable values. So you shouldn't use for authentication for where you set in a cookie and you receive anything that is predictable. And you shouldn't use anything that can be reused. So in this case, if somebody breaks into the JavaScript of that site and is able to steal the cookie, it would have full access to username and password. That means that, you know, it can authenticate for the rest of the lifetime of the application, can authenticate without problem. So, of course, what is done is create a session ID that is, you know, your username and password are verified. They create a session ID, and we saw that, you know, we examined how PHP at a certain point used to generate their session ID. That session ID is set in a cookie, and then everybody's happy. And you can see, you know, J2EE, PHP, ASP.NET, they all use some form of this concept. Of course, there are a few interesting caveats. For example, if you have the referrer header that tells you where a page is, and you happen to use authenticators in the URL as part of GET, that might end up in the referrer and might be disclosed to a third party. So, important rule, never put the session as part of your parameters, because this is sensitive information and can be disclosed in a number of ways. And so, you know, you would see the referrer. Note that referrer should have 2 R's, but it's actually like this in the HTTP protocol as being set as misspelled. For an, you know, anal retentive person like me that is always, you know, fixing the spelling and the grammar of things, it's always terrible to having to witness this impossible to correct obvious mistake. But it is what it is. And so you can see that in this case, since somebody clicked on the www.bar.com from a page that was initially requested like this URL is included in the refer, and maybe no one notices, but in a way is giving out your authentication code. Of course, another important thing is authentication should not be long-lived, so that if they're stolen, at least they will not be able to impersonate you forever. One thing that is important to understand, for cookies, you can set the cookie to, you know, remember there is an expiration date in the cookie when you set it. That is something that the browser uses in order to, you know, get rid of stale cookies. But if you have a malicious guy and you stole the cookie, you cannot rely on the browser stopping to use that cookie. You have to keep on the server side meta information about that cookie, that session, the expiration, and act accordingly. That's very important. And of course, the expiration date should be part of the creation of the cookie itself, so it cannot really be sort of separated by the session itself. And of course, if you're good and you know what you're doing, you would do something like OAuth or other form of third-party authentication, where you actually fundamentally have whenever you have an authentication request, you are sort of redirected to a different page. That page will send you, for example, to Google saying generate a ticket for this person. Google will authenticate you, give you back a piece of information that you go back and present to the application, say, look, Google authenticated me, and that application will verify that information, and that matches whatever the requirements are, you will be authenticated. This adds a little bit of complexity to sometimes analyzing application, because you bounce back and forth sometimes several times. For example, if you check, I don't know if you have some websites, here are UCSB, sometimes you get redirected to sso.something at UCSB. You will see that you actually go through several layers of redirection before you get to that little form where they ask for username and password, and then when you put your username and password, you're brought back to where you were initially. And following and being able to handle that whole series of requests, it's always, sometimes it's not trivial. How do you attack the authentication process? Of course, you can just sniff the traffic, observe in some way. You can brute force or guess the actual authentication mechanism. If it is predictable, if it's long-lived, is even easier. Or you can bypass authentication. We will see you can do that with SQL injection, but also with a technique called session fixation. The eavesdropping, I have just a fun story about 2005. I was at one of the top conferences in security, and I was, for some reason, looking at the network, and suddenly I see the actual chair and his password appearing on the wire, and I was like, we're at a security conference, and we're not able to get, web authentication right. So yes, this was 12 years ago. That dates me quite a bit, but it was happening at rate 2005. Good times. Of course, for example, the cookie secure flag makes sure that you don't do an error. This is because everything was happening during the PC meeting in a way that was not encrypted, and we were all among friends. Setting the cookie secure flag would have allowed this. I mean, it would have would not have prevented this, but in case they use cookies, they would have sent the cookie only on an encrypted connection. Of course, you can have other things that are erroneous, like using 4-digit pins for application, or sequential session IDs. You'll be surprised. Of course, nowadays, if you use PHP or J2EE, this will never happen. But then there is always the guy that decides, I'm going to run my own session ID system, and I'm just going to increase the last one because it maps nicely one-to-one to the lines in my database. It's not very good. Also, sometimes, you have something that you just logged in at 3:10 p.m. on November 7, 2017, and say, oh, look, my session ID is 1711091510. Yeah, I think that there are fundamentally 4 numbers here that I have to guess in order to get the right session. So understanding how session is chosen is an important part of pen testing a web application. If you see, J session ID or PHP session ID, chances are you're not going to break that. But if you see a session ID that is kind of, obscure, that is not from a well-developed framework, who knows? It could be a good thing. You say something? No. Except if you're SEMI, of course. Of course, you can also use, as we will see, SQL injection or other technique to bypass completely authentication. You can also use password recovery system. Suppose, for example, that you have control over the email address of somebody and they want to get into a web application. Reset the password. You will get the email and suddenly you will get access to the web application itself. And we will see authentication can be bypassed using forceful browsing, which is a way to actually completely bypass authentication and sometimes even authorization. And we will see also how you can bypass authentication using execution after redirect, EAR. It's a type of vulnerability that is associated to the redirection process. Another common thing that you can do is session fixation. How does that work? So the basic idea is who decides what a session is. Suppose that you have an application that has been developed by an not so careful person, and they say, okay, when people log in this case is the bad guy, but this follows a completely normal interaction. The bad guy logs in, and the bank say, oh, your session is, a certain thing. And so now, every time you ask for something, you pass the session as a parameter to the interaction, okay? Now, suppose that what the bank here, a bank would never make this mistake, but basically they say, okay, you come with this, therefore, this is your session. I'm just going to use it as a key to get to your stuff. Now, suppose that the attacker is now able to present a page to the user, because say, I love cats, there is an iframe, and suddenly I can inject some malicious link that forces now the victim to log in, okay, and passing as a session the session that has been set up by the user. So in a way, you, during the login process, direct the session. This is the bug of the web application, to accept at session establishment already a session. There were a lot of applications that would just say, oh, if you have a session, I'll use it. Fine. Why not? Okay? Instead of saying, hey, you're logging in, this will destroy your session. I will ignore anything you send me, and I will send you a complete different one. The bug in session fixation is that if there is a session, the application decides, I already talked to you, so I will go on with that particular session. Because how would you know this? I mean, this session ID is, 5 numbers is ridiculous. But suppose that somebody comes with a super long session, okay, and the bank say, well, how would you know this otherwise? Obviously, you're that guy. Or you're logging in. Great, come in, okay? But at this point, the problem is that this person will have also access to the session, and so could log in now as you into your web account, okay? So in some cases, you don't even have to do the first part. There are applications that are so broken, they will just accept the fact that you pass a session and give it to you. It doesn't have to pre-exist, okay? That's, of course, that would be super, super crappy web application, but this was actually the reality. And so these allow an attacker either to set up a session and then convince you to log in with that session, or simply tell you, hey, log in with that session by providing you a malicious URL. And by doing that, since they know the session ID, they can access your information. So lesson learned on this. Authentication is super important. I don't have to really stress this part. Do not transfer stuff in the clear, of course. And do not use stuff that is repeatable, predictable, or long-lived. Those are important things. Okay? If you create something that can be predicted and lasts forever, then you don't have a good authentication system. Do not allow the user to choose their own session ID, and possibly use good authentication services. Do not reinvent the wheel. Most of the vulnerabilities that we see in web applications is because somebody decided, hey, I'm going to go with my own version of this, while there are frameworks that already provide you with all that functionality. Another interesting thing is forceful browsing. This is interesting because it's a vulnerability that is actually specific of web applications. Because this is really, I think, one of the most excellent examples of the difference between what the developer has in mind and what you can actually do. Because when you develop a web application, you imagine that the user is clicking on this, clicking on that, putting this, and is interacting with the interface that you present to the user. But a web application is just a bunch of URLs that for which you will provide some content when they're called in a certain order. That's it. So there is nobody that, I was pen testing a company that was selling digital goods, and you have to authenticate before you get to the URL for these very expensive, they have all this digital information. And say, what if you already know the URL and you just put it in the browser. Of course, it would immediately serve you the information without the need to go through authentication or anything like that. That is sort of the way in which forceful browsing works. You do not follow the sort of the intended flow of the application, but instead you push whatever resource you're looking for. And this is good because this can be oftentimes automated and also can create interesting situation with a web application depending on the order of certain operation. Because flow is not only, oh, you have authenticated and therefore I will show you this, but it's also like, oh, you will always fill the cart before checking out, because that's the workflow that I have in mind when I design the application. So what if you decide to check out the cart, pay, and then go back and add more stuff to it? Will the application be able to deal with this situation? Or you will get a shipment for all the stuff, okay? So this type of interaction are due to the fact that fundamentally a web application, who puts a highlighter that is permanent in a class? I think they're trolling us. So you can see an application as a bunch of entry points. So, which is really, an API. So when you have an API server, you really see, oh, this is my login thing. This is my write. This is my read operation. But the developer doesn't see this view. The developer sees a bunch of user interface thinking, oh, when this happens, the state changes, and I will show this other thing, and so forth. Actually, the user can independently call any of these in any order. And this creates all sorts of different security problems, inconsistency in the application, and especially logic flaws. So things that are very difficult to detect, like in the case of the cart. The fact that you check out the cart, your credit card is charged, then you go back, you start adding other stuff, and then you receive everything. How do you automatically create something that verifies that this cannot happen? It's one of the big challenges in automated security. Another authorization attack, very similar to our directory traversal attack. Every time you set up or you access some file in your back application using a path that receives information from the user, if you don't sanitize correctly, suddenly you can, of course, do all sorts of shenanigans, read path file that you shouldn't read, and so forth. Note that a lot of these attacks work with a bunch of encoding. And so this makes sanitization a lot more difficult, because your string, the same string that you see here, can be encoded like this. So it's like, oh, I'm looking for ... Well, maybe you don't see exactly ... but you see the encoded version of that entity. And of course, you have your wonderful directory listing. This is another example of the difference between the mind of the developer and what it happens. This is the lowest possible hack that you did by mistake, right? You just had something, you put the URL without index.html, and suddenly you got all the content of the directory, including files that you shouldn't know are there and things like that. But it's an authorization attack per se. And this is because the lesson learned here is that all resources are paths. Everything in a web interface is a path plus a query string. And so if you can predict the resources, then you can get there. And it's up to you to have a constant state in this application that whenever each of these elements are requested, say, okay, this is the session. Given the status of the session, can the user request that? Okay? Because otherwise, if you don't have a continuous internal consistency check that makes sure that the state of the session allows for that operation, you are prone to all kind of authorization attack. Another interesting one is, for example, parameter manipulation. So in this case, suppose that you start observing that there are parameters where there is a user ID because you are the one that you are authorized to use. And you say, user ID 1229. What if I put 1230? And suddenly you get the records of somebody else. That's a classic authorization attack that works in an enormous amount of situation. Actually, I think one of the most successful pen tests that I ran in my past was really in a very secure application, and the only problem that they had is they forgot this. They forgot that having predictable IDs that you can enumerate, and there was not for numbers, there were a lot more, but you had a high chance of hitting one of those, and after a while we could fundamentally download all their content by just going from object ID to object ID by guessing it. And of course, here if the parameter are also blindly imported, you can use parameters to modify the internal state of an application. So suppose that in the code that processes this, there is something that says, I'm going to take every single variable and set it to the value that is described in the URL. And the developer is like, in the code there is something that checks some admin variable. There is a global variable of some sort. And by blindly setting this variable, if somebody adds an additional variable, can introduce state in the execution of your code. Yes?
So you mentioned like the user ID making that not predictable, but what if your user ID has to be something predictable, like a perm number or something?
Well, then you have to make sure that the person that is issuing that request has authorization to access that particular record.
Okay. And how's that done exactly?
You will have in your database a model of your application. So inside here, there will be a table in a database that say, user Vigna can actually access only, 1228 and 1229 because of the record of his kids. And suddenly, when I do for 230, instead of saying, 230, here's also 230, they will say, no, you're a certain user, and therefore you can only access, the record of your kids or something like that. Interesting enough about this particular thing is the famous register global. And this is a classic example of why PHP was so great and so bad from the security point of view. So somebody say, let's make it super easy. Whenever somebody asks you a PHP thing, all the variables in the parameter, we're just going to create variables in the code for you, already initialized. So you don't even have to read from the thing. We just create those variables for you. Everybody's like, this is super easy. The problem is that if you have something like this, you say, I'm going to get the password, and if it's secret, admin is equal to true, and if admin is true, then this is, all the admin functionality that allows you to do whatever you want. Suddenly, you do exactly what we did before of passing admin equal 1. You don't know the password, but when you get to here, since it automatically created every variable that was in this request for you, you will be able to execute admin functionality. So this you can see really how somebody did a pretty serious mistake from the design point of view because he was trying to make it extremely usable. They want zero attrition. The idea was like with PHP, anybody can develop websites. This was before frameworks when everybody was going crazy and really wanted to allow the creation of everything. The problem is that this was on by default. After 4.2.0 is now disabled, and you actually have to enable through a configuration file, and nobody does. But there are a lot of people they find very useful, so you will find, if you look on the net, little snippet of PHP code that will reproduce exactly the same behavior. So it's like, must PHP doesn't have register variable. It's so nice. So I create this loop that goes through all the variable in the GET request and create variables dynamically in my code. So effectively bypassing, any protection, which I think is awesome. I mean, it's like how people shoot themselves in the foot continuously. Another interesting type of attack of this kind is parameter pollution. This is actually relatively recent. Somebody find that there are some websites that are vulnerable to this. And fundamentally, it's like, what happens if you have the same parameter with two values? You take the first value that you see, you take the last value that you see, or even you put them together in a list. Okay? This is actually, in a way, web server dependent. Okay? And if somebody took this and say, wow, if I could, in a way, modify it and have a situation in which the value of my parameter is used to actually create the web page, then I could, for example, if the one is the last and I can add another color equal blue, I could change the semantic of the website. So imagine this situation. You have an election, and the basic idea is when you have the poll ID, okay, there are two candidates and one is white and one is green. You vote and something got added because of the candidate that you vote, okay? And you are identified by the poll ID. Now, if the attacker provide a poll ID that is a number, but then also has something to say ampersand candidate equal green, okay, this might end up here. So in the case, it might end up here. And in this case, the link will have green instead of white. And if the first value is the one that is used instead of the second, suddenly you have inserted in the link a new parameter. And whatever link you will click, you will vote for the green guy. Okay? So all these injections, every time you seem confused. You didn't get it? So look at this. The main problem here, you see that poll ID, that is provided by the user. Say, I am some identifier, okay? You provide that to the application uses this identifier to create a set of links that you can use to vote. The main problem is that value is created to put together a link. Normally, you wouldn't have this part. You would be, okay, vote, poll ID is this guy, white, vote, poll ID is guy, green, and so whatever you click, you will vote for Mr. White or Mr. Green. But in this case, there is no sanitization, and the value of the parameter is just inserted and put in the URL. Now, here, you pass a value that has this character encoded, which is an ampersand, and this character encoded, which is an equal. So when your poll ID that is this long gets put here, instead of being only for 568, as also this additional thing. Because if you have the same value for a parameter, you have, I would say, unpredictable results. In this case, we assume that the green candidate would be chosen. With this attack, these two will always vote for green. Yes?
How is this any different than just giving them the same link twice, like the link for green, and then just having it say that it's white?
Because the application from you takes only that value. Mm-hmm. You don't give them all the information. They take one value, which is your ID, and using that value, in some way, they create these two links that they present to you or to present to a third person. Mm-hmm. Okay? And so suppose that you present it to a third person, and then suddenly you have polluted the web page in a way that modifies its behavior.
So the page itself will say white, even if you're
correct. The text would be vote for Mr. White. But when you click for vote for Mr. White, because you added this additional candidate equal green, the voter will be counted for the green one.
But even if you deleted the ampersand candidate equals white,
but you cannot delete. You can only add. You can only inject.
Okay.
So you can see that this is the parameter that is copied from your original request. So you add this thing. You cannot delete. If you could delete parameters, you can have full editorial capability on your page, and you don't need all this.
But how
Okay.
would this be any different than just giving them a link to any arbitrary site that you control?
Well, I mean, this is different because in this particular case of injection is using this to overwrite a specific parameter by causing this double parameter override. Of course, there are situations that we will see. What if I give here as my session ID close quote, close dash dash something, so I completely escape the string context and I start generating my HTML. You can also do that, and we will see examples of that.
I mean, you can think of it as, let's say you have Doodle, for example, that lets you make like these questionnaires where you can answer something. And Doodle lets you put a name that has this problem. And you put into the name, you will send an invite link to all the invited people, and you will send them that link, hey, vote on my Doodle. But because Doodle generates that invite link that it will send out using this, having this kind of problem, you will actually vote on someone else's Doodle instead.
Correct. Of course, Doodle doesn't do that because they know what they're doing. But that's a great example. I can see you going to Doodle, the moment the class is over, attacking half of the planet with malicious JavaScript on a Doodle as like, oh, no, Giovanni told me to do it. Of course, there are other things that can go wrong. Another problem is server misconfiguration. It's actually interesting how this came in the OWASP top 10 vulnerabilities in 2017. But fundamentally, every time you can influence the state of the web server or the web application through a side channel, you can create all sorts of problems. So if you have, for example, the web server shares a directory that people can upload file on, and then you decide, oh, I'm going to upload a file called, mycode.php, and then you request that code, the server will execute your code. So this is actually a lot more common than you might imagine. If you can upload files, first thing in a pen test, you check, hey, what if they ask me to upload an image? Do I have to upload an image? What if I upload .php file, .asp files? Will they be executed when I ask for them back? And so this is a way to, again, create server-side execution through this interaction. And in general, as we are seeing common injection in binaries, there is also common injection in web application, okay? And stems from exactly the same problem, the fact that you take some input, you don't sanitize it well, you pass it to something like system, eval, popen, include, require, that will trigger the execution of that content. In the case of system, it could be a bash thing, but it could be also any kind of PHP code or JavaScript code, whatever has dynamic evaluation and parsing of information, okay? And this can be, of course, language specific. If you think about, the classic CGI implementation, suppose that you want to do grep on the user input on some phone book because you say, hey, I create this awesome CGI script. I have these text files with all these, names and numbers. I get it for the user a number. I will just do grep on it, okay, and I will just return whatever I see. The problem is that to do this, you use system, and so this whole string is first built, then interpreted and executed, okay? And this is really all the SQL injection, the common injection are all based on this command. That first you build, and then you parse. Instead, it should be that you parse, and then you execute. You parse, and then you build and execute, okay? But if you build first and execute later, you will be injectable, okay? So in this case, obviously, you can, I'm going to add foo, semicolon, echo some long, SSH key into authorized key, and I put a nice RM at the end. So not only I will delete your phone books, but I will also add a secure shell key to your, secure shell key storage, and I will be able to, log in as you. Okay. Of course, the guys say, haha, you will not be able to escape this because I'm going to put the quotes around this. And of course, you can just escape again the escaped quote and, and break out of that. But this shows really, it sounds funny, but it's really difficult to understand every time you're parsing a string, what is your current context? And there are, papers in top conferences whose all analysis is focused on determining in a provable and correct way the correct context in evaluating HTML, evaluating JavaScript, so that you are executing the right thing at the right time. Of course, the right thing to do is to, already parse first. So by using system as a list, okay, we know that this element, whatever you put in it, is going to be argv something. It's not going to be parsed by the shell. It's like the difference between, doing system, but this is equivalent to an execv, where I say, this is my argv 0, 1, 2, and 3. Here you can put, the whole, the works of Shakespeare. It doesn't matter. It will be one parameter, okay, and will not be touched otherwise. And so it's more secure. An interesting thing that is nowadays very seldom seen unless you're working with in a CTF or something like that. But in the good old time, there were server-side includes. So once again, to make web pages more interactive, easy to use, they invented a simple concept where you would put within a comment in your HTML something that did a configuration, printed something, included a file. It was used a lot to include banners or files that you need to repeatedly include. But they also have the exec file. So guess what? If you have server-side include available and the user is able to provide input that will be used as part of the page, then can provide something like this in which you can execute arbitrary command. And in the good old time, guest books were awesome for this. Guest books are those type of application where you can leave, comments. Nowadays, they're super sanitized, of course, because you're in 2017. But in the late 90s, you could put all sorts of things. And that text would be taken and then reproduced to you, whenever you ask for it. So we will see that's a source of, cross-site scripting attack. But if you have a mechanism like server-side include, again, you can execute something that puts, a secure shell key in a configuration file. We're going to stop here, and we're going to see you on Wednesday.